question 6.7, and this is question number 3. And I'll share the screen now. All right, so let's look at that, and we'll use that. But what is, since that's kind of what we're talking about today, what is that thing called? It's not a trick question. It's actually just right above.
The system of equations.
Good. So it's called a system. What is a system? If you were to explain it on the telephone to somebody. So think about having a niece, nephew, or if you have children of your own, you know, if they're in kindergarten or something, and they, you know, how would you explain it to them? And that's a trick you can always use to try to figure out how to put things in a nutshell.
I had a question about the lecture video. Do we have to, like, you know, they give different ways to do it. Do we have to know all of the different ways to do it, like with the graph and then substitute and all that stuff?
It's good to know all of the ways, but you really only need to master one, because at the end of this unit, you're going to have a feasible region on a graph. And so that it's created by a set of lines that are going to like enclose a region. And you just need to be able to find the corners. We call them vertices. So
Okay.
the vertices are where the two lines intersect. And so that is a solution to a system, right? So one of the methods is by graphing. In graphing, you graph the lines and then you find the intersection point. The second method is by the substitution method. And we'll talk about that. That's when you solve one line for a variable and then you substitute the other one and solve. That's it, that one in a nutshell. And then the addition/elimination method is the one where you multiply one or both of the lines in a way such that when you add them, one variable or one term is eliminated. So that's the addition/elimination method, because then you solve there and then you substitute. Okay, and that's that one in a nutshell.
Which one do you recommend to do?
Most people prefer the substitution method. You can always kind of rely on it. If you were to go on in math and take a linear algebra class where you have matrices, if you've ever seen a matrix, it is, a matrix looks like this. Oh, I'll actually write this as a matrix. 2, 3, 5, -4, 6, -8. So if you were to take a linear algebra class, this is how you would write this system. And then you basically use the addition/elimination method to solve it. So substitution tends to be one that's like always reliable to, you know, that you can always rely on it and it'll always get you an answer without too many steps. All right, first I'll solve this by addition/elimination method. Now, Wills, which terms do you want to eliminate? Do you want to eliminate the x terms or the y terms?
Does it really matter where you start?
No, but you have to decide which one you want to start
I want to eliminate the y terms.
Okay, good. So we now want to multiply this equation. Sometimes you only have to multiply one equation, but in this case, we have to multiply both. You want to multiply it by a number such that these two will cancel out. So
I multiply the top by -4.
+4.
Okay.
And the reason is you want to have it be the least common multiple. It could be actually any common multiple. It doesn't have to be the least, but the least one helps you get like smaller numbers. So you think to yourself, what's the least common multiple of 3 and 4? And that's 12. Then you want to say, okay, I want to get a +12 and I want to get a -12. that's opposites, and when you add them, they become 0. So that's your goal now, to get a positive 12 here and a negative 12 here. You could say negative 12 here and positive 12, but we already have the negative there. So let's just use it, less work. So I chose positive 4 so that we get a positive 12 up here. And then I'm going to choose what down here, Wills?
Positive 3.
Yeah, positive 3. And how did you know to do that? That's the winning question we always get. Does everyone see how I chose those numbers now? Okay, good. Because the end goal, you have to look at the end goal and work backwards. The end goal is to have those two cancel out. Okay, so then here's another question. If I wanted the x terms to cancel out, what numbers could I have chosen?
10.
That would have been the number we want to get to. So 2 times probably negative 5. And then you could say 5 times 2. This way you get a negative 10 here and a positive 10 there. All right, good.
Wait, so are you just like swapping them?
Not swapping. I'm rewriting the equation. But I'm rewriting in a specific way such that these two will cancel out when I add them.
Okay.
Oh, I think swapping, I think you're thinking of the substitution method. That's more like a swapping situation. Okay, so then what do we end up having? So make sure you distribute those numbers, and we get 8x plus 12y equals 24. And then here we get 15x minus 12y equals negative 24. Great. I see opposites there. Now I'm going to add them. So different textbooks call it the addition method and other ones call it the elimination. I call it both. You can Google it and you can get both. All right, so when I add these now, look, those cancel, and that was my goal. It would get eliminated. And I have 23x over here, and then I have 0. Okay, good. Now we have to continue solving. So what's next? How do I solve for x?
I see what I did wrong, by the way.
Divide.
Divide by 23, because you want to get a 1x. Ah, so if you made a mistake here, my guess would be, and this is a common mistake, you didn't distribute. Either you didn't distribute to these, or you didn't do it to the other side. So that's all. Just remember, when you multiply one side of an equation, you must multiply the other so it stays balanced. Awesome. Now we've got x equals 0. All right, so we were just saying that the solution is the point of intersection. I think we were saying that. Okay, so this is just one component of the solution. We need to find the y.
Wait, quick question, because I haven't did this kind of math since like high school. Can we also do the elimination method with y as well, right?
Yes, so you could have eliminated the x terms there.
All right, because this is like a real throwback, and I'm like I remember doing this back at high school. All right, so
Good. Did you like it?
a little bit. Just to be honest, like only because of this method. But if you're gonna tear us another method, I mean that's more simpler, then I'll like that even more, because like I don't want to keep like filling out my paper with like, all this work.
They're all three methods can be simple. It depends on the problem that's given. So like with this one, the addition/elimination method would be the simplest way to do it. There are some other problems with the way that they're posed. It might be easier to do substitution or graphing. So it depends on the problem that's given. And I'm glad you kind of enjoyed it. And that's kind of the point I want to make now, because I feel like a lot of you might have had bad experiences or you didn't like this, but remember that there's multiple ways to solve this. And yes, they involve multiple steps, but nothing worth achieving is easy. Nothing worth achieving is easy.
Are we gonna go over finding why?
Yes, I'm just
Okay.
doing a little tangent here.
Okay, sorry.
Yeah, and so this is our growth mindset motto for today. I am capable of making smart decisions for myself. This one I just picked randomly before for my other class. So I'm guessing it'll resonate with some of you. But yes, so there's a lot of steps in some of these problems, and that's what turns a lot of students off. But I want you to view that as like an opportunity to feel so rewarded at the end. Remember, nothing worth achieving is easy. If it's easy, then nobody wants it. And it's like, aha, whatever. You have to do some steps and some challenges. And then at the end, you're like, whoa, that feels amazing. So when you're done with these types of problems, that's how you should feel. You should be like, wow, I did that. And be, so and keep getting to that point and keep aiming for those feelings. All right. So we are going to find why now. This is the next step. Tell me what I should do to find why.
You can plug it into either of the equations.
Good, you can do either because it's a solution to both of these. So I'll just use the first one. So we've got 2 times x. I'm not going to write x though. And you want to use the original because you never know. You could have made a mistake when you multiplied, because in theory you could use this one, but it's good practice to always go back to the original of what's given. All right, so we've got x equal to 0. Actually, I wanted to put it in a different color. So yes, you're substituting x equal to 0 in there. That becomes a 0. Then we have now 3y equals 6. Divide both sides by 3. Then we get y equals 2. So our solution is an ordered pair because it's a point on the graph. And it's the point where those 2 lines intersect. How can we check our answer?
Plug it in.
Plug it in, plug it in. All right, where do we plug it into? The entire system. All right, so we've got 2 times x plus 3 times y equals 6. It's got to be a solution for both, so you got to check both. Okay, so then we've got 0, 2, 0, 2. And then you can check it out.
Is the check, like if we don't check on like a quiz or a test, do you mark points off?
No, but ultimately you will probably lose points because we all make little mistakes. And if you make a mistake, then, so it's always good to check yourself. When I was a student, I used to kind of rush through the exam. Well, not rush, but I would go full steam through the exam without doing too many checks. And then at the end, when I had extra time is when I would go back and start checking all my work, because you never know if you're going to have that extra time. But I would never be somebody who would turn it in early without checking my work. But sometimes, yes, you don't have enough time to check. So you just still have to go full force through all of the questions first. Okay, so now here I have 3 times 2 is 6. 6 equals 6. That one works. Okay, then here you get -8 equals -8, and that checks out. So that's good. All right, we did this with the addition/elimination method. Let's do the same one with substitution.